Well,
Hi.
that was fascinating.
Yeah, my computer is not liking that. Hi, I'm Tom Dean. I'm a field engineer here at Buoyant, and I'm here with Flynn.
Hi there. See, that sort of thing is how you know we do these live.
And so we're going to talk about metrics today. And in the invitation, I'm going to quote it. I couldn't have said it better. Observability is one of the core features that Linkerd brings to the table, and metrics are one of the most important and least understood aspects of observability. And I think the whole statement is true. We've got
Okay.
just observability and metrics lately on our at least on my team working with customers are hot topics around Buoyant. Linkerd and its extensions emit a plethora of metrics, especially when you start adding things onto it that can be used for troubleshooting, which we do, and to meet other operational goals. Again, least understood. This is something where documentation's constantly evolving, right? So every
Well,
day,
to the extent that the documentation's there at all, right?
yeah, like again, metrics, we keep adding more metrics, so it's catching up, right? But there's a ton of stuff there. We're going to show you today how to leverage it. And again, we're going to get this stuff wrangled into documents as well. So back in the day, since Flynn and I are both pretty old, we kind of wish we had this kind of visibility into our applications and networks, right? We used to run bare metal servers, limited logging space. I mean, we basically had what we could put in the OS and whatnot, right? And we didn't have a capability to log things. We didn't have all this fancy software that we have now.
I
Um,
have literally used serial ports for
yeah,
logging because that was
like hooking machines together, right, and looking at
yeah,
console messages.
terrible.
Network switches, you had to sniff packets off the wire if you could get a promiscuous port. That sounds real bad, but
Yeah, well, it was so bad, but for different reasons.
yep. And you had to know how to pick through that stuff. And storage and IP networking were separate as well, so you really didn't have visibility into what was happening with storage, communications. Plus, all this stuff was layer 4, right?
Yep.
We weren't looking at high level stuff unless you knew how to pick packets apart and put them back together. Who has time for that, right? So with Linkerd, the service mesh and the data plane that we have, remember data plane's a collection of micro proxies. We now find ourselves awash in an embarrassment of metrics riches. And for some, this can cause observability fever. And we see this every week over and over again. We say, it's okay. I'm seeing this in the logs. Yes, first time I get it, right? We're surfacing things that you might not have seen before, but with
We
some work, you can tame and harness it.
we
So
literally have people every week showing up panicking about something, and the root cause is, oh, you never saw that your application was misbehaving that way before, and now you can.
yeah, it was DNS, right? Usually,
Always DNS.
yeah. There's things that fail too, right? There's things that hang up early and disconnect early. So those things aren't, you can learn how to kind of tame those things, how to set up your installation. We're not going to cover all that here, but it's going to give you kind of an intro into metrics and working our way up, right? We're going to learn how the pipeline works from the CLI up to consuming it in Grafana. We're going to understand some critical concerns around metrics collection and storage. There's a lot of ways you can get metrics, and depending on what your goals are and what your environment looks like, you're going to want to leverage one or more of them. And we're going to find out how to work with those metrics and solve problems and harness the power of observability. So here's Flynn, and he's going to take you on the journey.
We're not necessarily going to do all those things in the order that Tom just said, but we are going to do all of them. All right, let's get started. Yeah, we have the book. You should go check it out. It's really cool. On the agenda, we will be, how Service Mesh Academy, we usually try to do kind of heavy on the demo, light on the slides. And I'm sad to report that this is not one of those Service Mesh Academies. There's a lot of ground to cover as we talk about this stuff. So we're going to do that. We are going to interleave it with a demo. We're going to try to show how some of these things work at various levels of things. If you want to follow along, you can see the source in the metrics, dashboards, charts directory of the Buoyant.io Service Mesh Academy repo. I am using Buoyant Enterprise for Linkerd 2.16.0, which came out Tuesday?
Yes.
Is that right? Tuesday. Yeah.
Yes, it did.
You can do this with Edge 24.8.2 as well. I mean, they're, the same basic release. Some of the stuff I'm showing off here will not work with any older release. So really need one of these. I will also be using a K3D cluster for this. If you don't want to use K3D, knock yourself out. Nothing I'm doing in here is K3D specific. I do use the Prom tool Prometheus client, which comes with the basic Prometheus CLI installation. So that being said, let's talk about metrics. Let's start with a couple of definitions. Metrics. Information that is helpful for you to better understand what's going on with your stuff. And, some examples of these, the golden metrics that we talk about like all the time in Linkerd, request rate, success rate, latency. These are great examples of metrics. They are things that you can get the system to produce for you. You look at them to understand better what your application is doing. There are a lot of other metrics. We are going to talk about some of these. There's a lot of information, especially that service meshes can provide. I'm also making a distinction here between metrics and telemetry. Although these are often used interchangeably, I tend to think of telemetry being information flowing to somebody else and metrics being information that you get yourself. And we are talking here about metrics. Telemetry is an entirely separate problem, although you can build telemetry on top of metrics. The first law of metrics is something that Tom kind of alluded to there, which is that you have to know what you need. You have to know what you want to look at, because there's no such thing as a one-size-fits-all metrics solution. There are a lot of companies that would like to sell you a one-size-fits-all metric solution. If you look into it, you'll find that what they sell you is a thing that you can configure for your specific application. And so you got to start by knowing what you need. Specifically, you have to understand your application well enough to know what sorts of things you want to look at. Then you can use that information to kind of put together all the pieces of metrics to get the things that you want to see. It would be lovely if we did have such a, magic, I don't know, maybe ChatGPT will solve the world for us, but I kind of doubt it. All right. Let's take a very quick overview of the way the metrics systems tend to work. You will usually see metrics stored in a time series database. We could go into the rabbit holes of trying to do formal definitions of different kinds of databases, but instead you will get Flynn's rules of thumb, which is that non-relational databases are key value stores. Here's a key, give me a value. Relational databases, hey, here's a relationship. Please tell me about data you have that fits this relationship. Time series databases are weirder. Here's a metric. Please give me a ton of data points about that show me how it is changing over time. And one of the interesting implications here is that time series databases are basically never going to overwrite data. They just keep adding new data points for the metric as time goes on. When we talk about storage briefly, we will talk about the critical exception to what I just said. There are a bunch of things out there that can do this. RRD tool was the original. I bet you Tom had to use that one like I did.
Yeah, at Monster a long time ago.
There are a lot of relational databases that kind of claim to be able to do time series stuff. And in fact, there are time series databases built on top of relational databases. The major CNCF player here is Prometheus. And Linkerd, in fact, uses Prometheus. Really, almost all of the CNCF projects that I know of that do metrics in any way kind of vaguely like what Linkerd does use Prometheus. So we will be showing Prometheus syntax in here, and we'll be talking about some things that are Prometheus-y as we go. Prometheus, like every database, not just every time series database, has its complicating factors. The first one is this concept of dimensions. And what's basically going on here is that when you talk about storing a metric, you have to store data points across time, but also across multiple dimensions. And an example of this would be something like, you don't necessarily just want to talk about success rate. you want to talk about the success rate when deployment X is trying to talk to service Y. And that is different from when deployment X is trying to talk to service Z. So here we have deployment X and service Y are labels. And we talk about deployment and service as being dimensions of this data. You can write syntax-wise metric name and then curly braces and then put in a string of labels and then close the curly braces. And that says, give me this metric, but constrain it to the dimensions that match these labels. If you just talk about the metric name, you will get all of the dimensions that the database knows about for that metric, which can be kind of overwhelming. If you sit back and you talk to the people working on time series databases, you will immediately hear them talking about cardinality. We are not going to define really what's up with that. It's a measure of sort of how many different dimensions and how many different values and things like that that you have. But it's primarily a thing that you get to worry about if you are either writing the time series database or if you are writing the thing that is producing the metrics. If you're using the metrics, which is what we're really talking about mostly in this course, or in this session, I should say, it has more to do, the thing that you need to be careful of with the dimensions has more to do with not being overwhelmed by things. And so in general, well, we're going to talk about more, we will talk about this more in the demo, but in general, this is about how do you constrain your queries and such so that you don't get handed a bunch of dimensions that you don't care about. Complication number 2, time series databases have special data types. I'm not talking about like int and float and things like that. We have a gauge, which is a metric where the number can go up and down. For example, the number of endpoints that are currently blocked by circuit breaking. You would expect this to be 0, and then a circuit breaker opens and you would expect it to go up, and then things get happier and the circuit breaker closes again and you want to see it go back down, right? That is in contrast to a counter. I actually misstated slightly. Counters are allowed to stay the same too, but they can never go down. They are monotonically non-decreasing if you want the math. A good example of this one would be the number of HTTP requests that have succeeded for a given workload or whatever. Once a request succeeds, it can never be unsucceeded. And so a counter that's the number that have succeeded over time, it will just keep going up. It will go up at different rates, and that becomes important, but it's always going to go up.
Yep, it's like the odometer in your car.
Yeah, yeah. There's also the thing called a histogram. We will look a little bit at this, but I'm not going to talk too terribly much about them. But the thing here is you're going to take a bunch of data and then group it into buckets for later analysis. Latency is sort of the canonical example of this, where you don't just want to know the absolute latency. You want to know things like, what kind of latency did 50% of my requests finish in versus 95% versus 99%? And that is the canonical thing that histograms are great for. Prometheus also has a fourth thing called a summary. I had never seen that before prepping this particular SMA, and I have still never seen it used in Anger. So it's there. Awesome. I don't know why you'd use it. All right, all of this brings us to the third complicating factor, which is queries. Generally speaking, people who are writing the code that generate the metrics pick the data type that is the fastest and the simplest to generate, because you typically are instrumenting places in your code that you really do not want to slow down. If it takes Linkerd an extra 10 milliseconds for every HTTP request to update the metrics, no one will be happy. So, unfortunately, the type of thing that is easy to generate is almost never the type of thing you want to use as a user. This is just Murphy's alive and well, you know? So a good example of this is no one that I know of actually stores a success rate metric. That would be very, very hard to do, so nobody does it. Instead, people might store a counter where you have one counter for the total number of requests and one counter for the number of successful requests. Or You might have a single counter for requests where one of the dimensions is, did it succeed or fail? Linkerd actually takes that second route. So there is a metric called response total for it. It is a counter of the number of HTTP responses that have happened. There's a separate counter for the number of requests that have happened, and you can match those two up if you want to. There's a classification label on the response total. So you can see classification equals success or classification equals failure. And it also has a ton of other labels that we'll show a little bit later. But given those, you can calculate a success rate, but you can't just ask the system, please give me the success rate. Instead, what you have to do is figure out how fast response total with the success classification is rising, and then figure out how fast response total with any classification is rising, and then do a division. Because the first one will tell you the rate of successful requests, and then the second one tells you the rate of total requests, and successful requests divided by total requests is a fraction that we tend to call success rate. And you, of course, have to make sure that you do the right thing with all the other labels while you're doing this. This is a pain. Nobody really wants to do this. So that kind of math gets baked into the time series database itself. And you end up being able to make things like this, where we first take the response total with the success classification and whatever other labels you need, and then calculate the rate over a window of 1 minute, and then add that up by whatever labels you care about, and then you divide by this exactly the same thing, but without the classification success label. Thankfully, this is already baked into Prometheus, and you don't have to write all the math for it. Yeah, rate calculates a rate from a counter, sum by label. Actually, this is a good point. I'm glad I have this on the side, on this slide. Wow, I cannot talk today. I personally find it much more helpful to think of sum by label as collapse all the dimensions for this metric except for the labels I gave you. It's a little strange sometimes to think about sum as addition when you're also talking about rates and things like that. But what's really happening is you've got all these dimensions, and then you just collapse them down except for the one or two that you actually really care about, and you get useful information out of it. Oh, and Prometheus has a bunch of other functions that you can go read about in the Prometheus docs. But not going to lie, I've been finding that sum and rate and histogram quantile are, I don't know, they're the ones that I certainly see used the most, the ones that make the most sense to me personally for things I'm interested in. So, okay. With all of that being said, before we go into talking a little bit about the way the metrics pipeline works in Linkerd, Tom, did you have anything you wanted to add that you think I missed?
I think that's good. Like in the last slide, an example I use is like by workload, right? So if I'm looking to group things by workload,
Yep.
it could be by deployment. Those are some common things I do. And it just allows me to visualize things because the things I'm looking at are broken down that way, right?
And in fact, we do exactly that in the demo for exactly that reason. It makes sense.
The other thing that I've recently discovered in Grafana that is even equally horrifying, if not more, is that after you do your query, you can also transform this query. And it's an amazingly interesting journey, that I took of Googling and figuring out how to make that work. But to get to things like I have a little panel that computes like cross ZZ costs, over a bunch of things. And the only way I could get it finally into what I needed was to do some transformation at the end. So if you're not getting what you want out of the query, don't beat your head against the wall too hard before you explore transformation.
Yeah. Grafana is, actually, you know what? Let me hold that comment until we're actually
you'll show
at Grafana.
I don't want to get too far ahead, but
I'm not going to show any transforms actually, but if you're used to, those of you who have done SQL, transforms are kind of like subqueries in SQL. And so they can be ridiculously powerful and ridiculously complicated.
Yeah.
Yeah. All right. So let's talk a little bit about the metrics pipeline. And when I say metrics pipeline, you've got bits of Linkerd that generate metrics that then get fed elsewhere, that then get fed elsewhere. And there's this sort of cascade of tools that only make sense when you really look at them sort of as a pipeline as opposed to any single tool. Metrics in Linkerd are provided by both the control plane and the data plane. They are actually stored in the Linkerd pods, where the pods keep track of their metrics in a way that is compatible with Prometheus. They then make them available on port 4191 of any Linkerd pod. And then you configure Prometheus to go through and pull metrics out of all these things and build its internal time series out of them. When you ask one of these pods, please give me your metrics, you will get instantaneous values. You'll get the snapshot at that particular moment. Prometheus scrapes these things repeatedly, and Prometheus is the thing that actually builds the time series out of the metrics. You can get to these with the Linkerd diagnostics command in a couple of ways. We're going to do that. And you can also get to them via Linkerd Viz, which is really just a metrics dashboard. I don't think I have a slide that specifically talks about this, but the other piece of this is after they get into Prometheus and Prometheus goes through and builds the time series, then other tools get to query Prometheus to ask Prometheus to do things like we were just talking about with the queries. Viz is a particularly high-ish level, not particularly high level. Viz is a high-level client of Prometheus. It asks Prometheus a bunch of things and shows you the results. Grafana is even higher level. Linkerd diagnostics is very low level. I want to repeat here that the Viz dashboard does absolutely nothing except show metrics from a Prometheus instance. So if you want to replace Linkerd Viz, go right ahead. There's no magic to it. It has no special privileges. It's just a dashboard. The other thing that I should point out here, storage. When you install Linkerd Viz, you will get a Prometheus installed with Linkerd Viz unless you go follow the bringing your own Prometheus. Actually, from my point of view, the thing is over there. But unless you follow the instructions on bringing your own Prometheus, Viz will install its own Prometheus. Never, ever, ever use the Prometheus installed by Linkerd Viz for anything real. There are two reasons for that. The first one is it has non-persistent storage. So every time the pod restarts, you will lose all of your time series. And the second one is even if it doesn't restart, it's deliberately set up to throw things away after 6 hours. And that's the other thing I was going to point out, where I said way back at the very beginning that time series databases never overwrite data. Well, that's true. They don't overwrite data, but they will throw it away when it gets too old, depending on how they're configured. So if you're going to do anything with metrics in the real world, you need to install your own Prometheus. You need to feed it persistent storage. And there's, this whole class of management around making sure your Prometheus doesn't grow outside its bounds and all this kind of stuff, which we're not going to talk about here. But it is very, very important. Now, that being said, I, of course, am using the Linkerd Viz Prometheus for the demo because I don't really care if I lose all my data. It's just a demo. Things you do need to think about as you talk about managing this: how long do you want to preserve your metrics? There are people out there who go, yeah, we just need to keep it for a day. That's fine. And then there are other people who literally have their Prometheus set up to try to preserve a bunch of metrics for all time. And they keep throwing more disk at it and they kind of roll it off to secondary stuff. And there's this just massive process around keeping the Prometheus fed with storage. So this can vary an awful lot from organization to organization. Another thing that's worth thinking about is as we look over the metrics that we see, we will see that there are a ton of labels that come back when we look at stuff. For example, every single Kubernetes label on a deployment gets copied into the metrics dealing with that deployment. Those things, for me personally, are just never useful. So if I were going to go through and do a real job about my Prometheus management here, I would actually go and look up and see, okay, how do I tell Prometheus, just throw that away? I just don't ever need it. I don't want you to store it at all. I feel like I'm missing something here that I was about to point out. Oh yeah, high availability and Prometheus. This is also a major concern, although I did not put it on the slide. If your metrics pipeline relies on Prometheus scraping the metrics and then relies on all of your visualizations being able to talk to Prometheus, it's kind of important that your Prometheus not crash. And that's another thing you need to think of. Tom, you've probably run across some other stuff here out in the customer world. What else do you see?
I think it's a good point that you throw away the stuff you don't need as you discover. And the same thing, it's just like, anyone that's been using Linkerd for a while and is familiar with skip ports, any traffic you don't want to deal with on at the proxy level, you skip it. Same thing here. You're going to go and configure your Prometheus. The other thing is transforming metrics in Prometheus. You can use Prometheus to do transformations or to build combinations of metrics. So you might not want to do that at the Grafana level. You might want to actually build new metrics and you can do that there. Go read the Prometheus docs. I mean, there's so many things to do. Same thing with Grafana, right? What you can do there. But, Viz is a good point to get started if you're just playing around, but just remember
Viz actually works, really quite well if you are used to, if you're used to messing around with Linkerd and you want to look at things from the perspective of Linkerd and deployments and things like that. It's kind of nice, actually.
You could use Viz as a nice little, temporary collector as well, and just do the Grafana installation from the documents, and you'll get the dashboards, the OSS dashboards for Linkerd, and it's a great way to start picking things apart too. And you're going to get to see some of that, Grafana action here in a little bit. But if you just want to get your hands on and like duplicate a dashboard and play around with that, just do the the instructions that we've got. Let me scroll back up here at the doc site, and you can go ahead and follow that. That'll get an on cluster instance with the OSS dashboards, and you go under dashboards. You can take those, pick them apart, duplicate them.
Fun fact.
Good starting point.
Yeah, fun fact. Those directions are how I set up Grafana for this particular SMA.
Read all the instructions, because trust me, we've stubbed a lot of toes on those.
Oh my God, yes.
Don't forget the auth policy.
I was just going to say, I'm going to go ahead and point out the particular toe stub that I ran into. Don't forget the Grafana auth policy. And the other one, this was one that I figured out just like late yesterday. Make sure Linkerd's control plane is up and running before you do the Grafana installation in those docs, because the Grafana installation in the docs relies on Linkerd being up and running so that it can mesh Grafana. And that turns out to be very, very important.
Yeah, it's easier to do it right the first time.
It's so much easier. Yeah. All right. Let's switch over and hope the demo gods are kind. So far, so good. I am not going to show setting up the cluster. There's a script that's in the repo called reset.sh, which will go through and create a K3D cluster and install Linkerd and Grafana and Linkerd Viz, pointing to the Grafana that you just installed, and faces with emissary and emoji photo, and set up a bunch of stuff. The end result is that we have faces running, and you'll notice if you're familiar with faces, we see retries on timeouts happening there. We end up with Linkerd Viz, and we end up with some Grafana stuff. Part of the magic here is that we also have some HTTP routes installed, and brand new for Linkerd 2.16, we have a couple of gRPC routes installed as well. These routes, there's nothing special in them. All of these routes literally say, hey, if you see traffic going to, gRPC traffic going to the emoji service, route it to the emoji service. And the HTTP route is the same thing. You see HTTP traffic going to Smiley, route it to Smiley. They don't do anything special at all, but they are very important for metrics. So let's start by looking at what metrics are stored in the control plane. Don't panic too much. There will not be a quiz on this later. This is mostly just the Well, a couple of things. One is the shock and awe. Holy crap, there's a bunch of different metrics. But also that you can see that there's no time information here. It's just single values. We can do the same thing looking at diagnostics from one of the proxies. When we do this, we have to tell it which proxy we want to talk to. So in this particular case, I'm going to find my mouse. There we go. In this case, I'm going to look at the proxy for the face deployment in the faces namespace.
Yeah, we talked about this yesterday. Remember, like your perspective. So where you look at, like we're looking at where is this in the application? Is this a requester or is this a server?
This is the workload right at the edge of the call graph. So the faces GUI talks to the face workload. The face workload talks to Smiley and color.
Yep. So your perspective, it's like being at a party. Where you stand in the room is going to depend on, how you see things relative to other folks. Same thing where you're measuring and what metrics you're getting there. You have to kind of consider where it sits in the greater group of, application components, right? And what you're going to see there and what you would expect to see there.
One of the interesting things as well that Prometheus kind of does for you in scraping all this stuff together is it makes it a little bit easier to select your point of view. Since we're doing stuff on the command line here, it can be a little tricky. But if we do this, we get another entirely different large batch of metrics.
That's a lot of metrics.
Oh my God. I haven't even gotten out of the response ones yet. All right. You know what? I'm going to give up. Yes. Goes on forever, right? Now, we can do this a little bit differently by going through Prometheus instead of speaking directly to the proxy to say, hey, give me your instantaneous metrics. We can just go to Prometheus and ask it, please tell me what you know about the time series that you have. And we are going to start by port forwarding. We're going to start by finding out that I already had a port forward for the Prometheus instance running. But yeah, just ignore those error messages there. And what we're going to do here is this starts with prom tool query. This is a little bit of an abuse of Prometheus. I'm saying, hey, prom tool, go run a query against the Prometheus at localhost 9090, and I'm telling it to match absolutely any metric that has a namespace equals faces label. And when I do this, I will get, again, just a massive wall of metrics. I am going to point out a couple of things here. The first thing I'm going to point out is, let me go on a little bit. All right, here's one metric for one thing in the faces namespace. And this is the name of the metric with that __ name thing. And all of these, what is that? A little over 4 lines of text. All of those are labels providing dimension data. Actually, I can
one instance of one metric.
From one instance of one metric. And it occurs to me I can make this. Oh, that was a bad idea. All right. I should have resized that window before starting. Oh, well. Yeah, one instance, one metric. Lots and lots and lots of labels. This is why I was talking about you do kind of need to be a little careful about which of these you actually look at. Now, we can also cheat a little bit further as long as we're cheating. Run the same query again, but then run it through sed. And I'm not going to explain the regular expression, but it basically boils down to take everything except the quoted string after under name under equals and throw it away. So if we do this, we should only get the names, and then I run it through sort-u to uniqueify everything, and that will give us a set of names that, since they're sorted, become easier to see the groups that they land in. So we've got a bunch of stuff about the container and a bunch of things about control and some endpoints and a bunch of inbound things and then a bunch of outbound things, specifically outbound HTTP and a bunch of outbound TCP and some other stuff like that. And then buried in there, we also have request total and response total and these latency things. That starts to give us a sense of what sorts of metrics are available. And we can see that the names actually group fairly reasonably, which is kind of nice, because that gives us a place to stand to start talking about Linkerd's metrics as opposed to metrics in Linkerd. The actual metrics that Linkerd provides that you can start to work with and do things with. Our first group here, I should have included container in this as well, right? Control and container metrics. Names that start with control, names that start with container. Control are the control plane metrics and container are container metrics. For the most part, the control metrics in particular, and usually the container metrics as well, these are mostly things that you're going to be interested in looking at if a Linkerd maintainer is trying to help you debug something weird. Because for the most part, as a user of Linkerd, you should be able to not think too hard about the control plane. That's the morally prescriptive should, by the way. There are some things in here that are kind of exceptions, like there's a group of control identity cert metrics that will show you things about when your workload certificates are supposed to rotate and how many times they've rotated and things like that, which is kind of cool. I mean, that can be handy in some situations, especially if you're the kind of person who gets paranoid about certificate rotation. There's also, say again?
If you forget.
Yeah.
Wouldn't say anyone that might watch this would ever forget.
Yeah. Hopefully the workload certs you can't forget about, but there's also these control request and control response metrics that can show you things about your individual proxies talking to the control plane, which again, I mean, might be kind of fun to look at, although probably more useful when you're seeing some problem and need to talk to a maintainer about it. We have some inbound metrics, which are metrics about inbound requests. The most interesting to me are absolutely inbound HTTP auth allow total and auth deny total, because they track authorization successes and failures. There's also an inbound HTTP errors total metric that tracks, weird errors in HTTP. It will have a label called error, which will give you a reason like IO, or what was the other one I saw? I don't remember. Anyway, but so that gives you a way that you could start looking at stuff like, hey, is my network just completely dropping things on the floor or whatever? Am I getting weird HTTP errors? These are all counters, which means that you're probably going to end up using rate functions on them. The outbound metrics, these are the ones that are particularly interesting to me, mostly because they've brought in a lot of these are kind of new with 2.16, and we've brought some kind of cool functionality in here. The big one is we have outbound HTTP metrics, but we also now have outbound gRPC metrics, which is extremely cool because we didn't have those before. Very, very important. You will not get any outbound gRPC metrics if you have not defined gRPC routes. I'm not going to lie, this one had me very, very confused while I was putting this demo together for a little while. I was really concerned. But where Linkerd can synthesize these default routes for HTTP, it does not do that for gRPC. It's a little bit, it would be a little bit weird to try to guess what you wanted for gRPC. So we don't do that.
I will also say that sometimes folks forget the fact that if you have no traffic, you're not going to have any metrics as well. So,
oh, that's a great point. Yeah.
Make sure that you're generating some traffic and pushing some packets if you want to see something, right?
Yeah. This is particularly important when you mess with Grafana, because one of the downsides with Grafana is if you get the query wrong, it'll usually just silently return nothing. And then you have to make sure that silently returning nothing is because your query is wrong, not because you're not generating any traffic. And this
Yep.
is where it's really useful to be able to use PromTool or just curling directly. And we're going to look at that in a bit too.
Nice.
So these are kind of my favorite outbound metrics. There's a weird thing to say in some ways. Basically, they come with a lot of labels, and the labels split up into some interesting groups. We're talking about tracking outbound requests from something to something else. So the from something, you get a deployment label and you get a namespace label. To something, there's a group of backend labels which talk about the route backend refs, backend kind, group, name, and namespace. And there's a group of parent labels which identify parent refs, parent kind, group, name, and namespace. If you are familiar with, if I were familiar with my slides, I would remember exactly which slide I put this on. But if you are familiar with Gateway API, especially as it deals with service mesh, the parent ref identifies the service to which the request was directed, and the backend ref identifies which deployment, which pod it got sent to. So you actually get both of those on this metric, and you can slice and dice depending on which thing you need at any given moment. Sticking with these two metrics for a moment, the synthesized HTTP routes will have a label for route name HTTP and route kind default. And if you're using a real route, oh yeah, the synthesized ones won't show up for gRPC. If you're using a real route, you'll see route kind of HTTP route or gRPC route. You'll have a route group, gateway.networking.gates.io, and the route name will be the actual name of the real route. So that gives you a way that you can look to see things like, maybe is all of my traffic to my gRPC route foo failing? That might be a clue, right? We also have some backend response statuses metrics, which is basically the request ones that we were just talking about are talking about we're making requests going outward, and then the response statuses talk about what kind of response we got coming back. So it basically looks like backend request total, but the HTTP one also has an HTTP status label that will tell you the status code. It'll give you the actual number, not like 5xx or 4xx, but it'll give you 403 or whatever. This is a case where Tom's transform trick might be convenient to be able to turn some of the fours into just a single 4xx thing if you wanted that. You can also see error request timeout or error request headers timeout, and that's the primary timeout metric if you have timeouts set, which was a little interesting to see. There's a gRPC version of this as well. It's pretty much the same, except your gRPC status gives you the gRPC status with things like okay or unknown or whatever. We also have versions of these that don't split out things by the backend. They just aggregate across all of the backends for a given deployment and parent. You getting the impression there's a lot of stuff in here? There's a lot of stuff in here.
And when we talk about aggregations, like one thing I see constantly, because I do a lot of work with load balancer metrics, is it's very number of endpoint dependent. So you have to kind of understand what these things are doing and what they're related to. As you observe them, you'll be like, okay, and it will give you ideas on how you can either leverage them, or to get something that might not be measured, or how to again transform them into something that's useful.
Yep. We also have retry metrics in 2.16, which is nice. We get a metric for the total number of retries that were sent, the total number that succeeded, the number that we gave up on the retries because we hit the maximum retry count, and a number where we didn't send a retry because a circuit breaker opened. And these, again, have mostly the same kinds of labels as the other outbound metrics we've been talking about. So you get pretty good granularity on these. Tom just mentioned the balancer metrics. Anything with balancer in its name, and I've never seen it at the start. It's always in the middle. But anything with balancer in the name is talking about the proxy's outbound load balancers. This is not a Kubernetes load balancer service. This is an internal chunk of Linkerd. It's the thing that chooses which endpoint you're going to talk to when a given request happens. There are a lot of balancer metrics. We're not really going to get into these too much in this talk because we could literally do an entire SMA just on load balancer metrics.
Yep. Yeah, there's two main categories. Adaptive is the advanced, like the Hazel load balancing,
Yep.
and then P2C is power of two choices. If you want to Google that, it's based on that algorithm, and that's the thing that comes in, all Linkerd.
And then there are also versions that have neither of those and just say endpoints.
Mm-hmm.
And understanding the relationship between those three gets to be fascinating. But for our purposes today, with shiny new things in 2.16, you can look for the endpoint state pending in the balancer stats to find endpoints that have had a circuit breaker opened for them, which is kind of cool because we didn't have that before. We also have names starting with request and response. These are older metrics. They behave differently from the ones that I just described. They are not aware of routes. They're just aggregating a ton of stuff together. But they do use labels in some fascinating ways. Like there's a direction label that will say inbound or outbound. So you can conceivably use this in a single query to see things like, hey, for the face deployment, I want to pull the inbound traffic and the outbound traffic at the same time. It gets a little weird, especially because you don't have route granularity and some other things like that. So in general, it's probably better to use the dedicated inbound or outbound metrics if they have what you need, because that will be a little bit easier on Prometheus because you're going to be doing a little bit less in terms of dealing with lots and lots of dimensions there. Okay. I think I missed anything. I mean, I know obviously there's a lot of stuff I didn't cover. Anything in particular that leaps to mind is important, Tom?
Nope, I think we got it.
Cool.
At least what's in our brains, right? This is
Yeah,
again, multi-dimensional. It's enormous. It's a giant grid. There's 3D, chess that you're playing here, 4D maybe over time, right? It's over time. I mean, there's so many dimensions to it that you have to really understand what you want to measure. I tell customers, sometimes we get questions like, what are the top 5 golden metrics I should measure? I'm like, you got to kind of think of metrics as bricks or Legos, right? And unless you're troubleshooting a very specific thing, you really aren't going to use one individual metric generally. I mean, there might be an instance where you want to measure it and put it on your observability panel, but not that often.
Or at least it's always important to understand what you should be looking at in relationship to the rest of your application, right? Because exactly like Tom did not just say right now, we are in fact going to continue with the demo going, let's go look at HTTP retries. But honestly, we're looking at HTTP retries because it's brand new in 2.16. And so that made it kind of fun for me to look at. Also, because I happen to have a demo that does retries. So, why not? Like we mentioned, the most basic retry info we can get from the outbound HTTP route retry requests total. Say that 3 times fast. We really need 4 labels for the thing that I'm going to mess with right now. We want the deployment and the namespace to identify which request, where we're starting. And we're going to look at the parent name and parent namespace to identify the service to which the request is being directed. And we are going to cheat massively by using curl directly to Prometheus, both because, hey, this is Service Mesh Academy. We do things the hard way. But also because this turns out to be a really, really good way to get a sense of what your queries are really doing and what's actually happening under the hood. So the first thing we're going to do here is we're just going to say, give me all of the metrics that you have where the namespace is emissary and the deployment is emissary. I mentioned earlier to Tom, the way that the application works is that the GUI makes a request to the face workload. The GUI uses emissary for ingress, and so that means that from Linkerde's point of view, it sees a request from emissary to face. And then there's other stuff that happens beyond that. We can start, though, just by saying, hey, give me everything that started with emissary. And if we do that, as I mentioned here, this is the more human readable version of the request we're going to feed to curl, the query we're going to feed to curl. It's all crammed into one line in the actual command just because that works a little bit better. But if you read carefully, you can see it's exactly the same thing. And if we do that, we get, look at all these labels. Like all of these that show up from labels that I happen to have on the emissary deployment and things like that. Most of these are pretty irrelevant, but we can see that we are getting metrics back from this. We got one where emissary is talking to face in the faces namespace. We got another where it's talking to faces GUI. The faces GUI is the workload that actually serves the HTML for the GUI. And then we get a third where it's talking to Linkerd viz. Because the way this demo is set up, we actually use emissary to provide ingress for viz as well. And all of these also, you can see there's a single value here. So we've got a time in seconds since the epoch, and we've got a value. I find it fascinating that the value is always a string. I was a little unhappy about that, but you know what you're going to do. So most of those labels are just getting in the way. So if I throw in a sum by, I can tell it, this is the query from before. I can wrap the whole thing in sum by and tell it, just get rid of the dimensions that aren't the parent name and parent namespace. I don't need to see those. And if I do that, it's now much more manageable because I only have the specific dimensions that I care about. And I still have 3 of them. Also worth noting, by the way, is that this value is up in the 14,000s right now for emissary talking to the face workload. Remember, this is a counter. This is not some sort of a rate. So it's just going to keep going on forever. Honestly, the length of time this thing has been up, this cluster's been running for about 2 hours now. I'm a little surprised it's only gotten to 14,000. So since the only thing that emissary is actively talking to here is face in the faces namespace, I can go ahead and throw in an extra set of labels and tell Prometheus, you know what, I'm only interested in traffic from emissary to face. And that should bring us down from 3 metrics, 3 individual metric returns, to just 1. Yay. Oh, look, we've gone up a little bit. I think it was 14.1. I don't remember exactly, but, you know, ticking up. Now, let's turn that into a rate by wrapping this whole thing in the rate function. One other thing that happens here is that we throw this 1m in. I'm telling it, take my same query there, turn that into a rate, and calculate the rates over a 1-minute window. I could have used something less, but whatever. We'll do it over a minute. Why not? Oh, also, rates by definition are per second when you get them back, even if you tell it to calculate over a longer time window. So I'm really getting the average number of requests per second calculated over a 1-minute sliding window. And if I do that, now instead of a number like 14,000, I have a number like 2.4, which again, lower than I was expecting to see, but whatever. Finally, instead of having that just give me one instantaneous thing, I can tell it by tacking this 5m:1m on the very end, I can say, take that whole query, but now give me a time series for 5 minutes of data at 1-minute intervals. So this time, instead of 1 value, I should get 5 values, all fingers, not only 4 fingers. And so that's what I got. One other interesting thing here is if you look carefully at these values and then do a little bit of math, you will find that they are actually on 1 minute boundaries with respect to with respect to the epoch. So these are aligned on wall clock minutes as well, which is kind of nice. Now, believe it or not, that's the basis of basically anything we're going to do with this stuff. Is you go through, you figure out a metric you want, you figure out what kind of labels it's going to give you, and then you just start going through and gradually building it up. I'm sure there are people out there who are really good at this, who can just write the whole thing out from the beginning. That ain't me.
Yeah, I agree. And
So,
remember, Flynn was querying the API on Prometheus. You can also go directly to any proxy on port 4191 on that IP address from a container in the pod, or in the Kubernetes, on the Kubernetes pod network, and you can go and curl that. So if you're having like real low level problems, you can get metrics right there at the
yeah,
proxy level, or
you
anything,
will
right?
you will only get the instantaneous values, and you'll
Mm-hmm.
have to do things like query it, parse the results, wait 30 seconds, query it again, and then do your own math for that low level stuff. But candidly, if you have issues like that, that might be what you want to do anyway.
Exactly.
And I can also say that some of the engineers are toying a little bit with stuff like that just to see if it might be a useful thing to provide in general. So, watch this space. Um, all right, so let's go over to Grafana. Now, if I come over here to Linkerd Viz, since I have Grafana installed, I've got all of these nice little Grafana things, right? And I can click on this one by the faces namespace, and I see a dashboard. I have a confession to make. This is not the standard Grafana dashboard that you get if you go through and install it exactly from the Linkerd instructions. I've been playing with this one a lot. Kind of just for the fun of it. I think the only thing I did on the namespace one was to mess with this, but also if you go to the Grafana, if you go to Grafana from our, the Linkerd instructions, you'll see these warning things that all these panels need to be upgraded away from Angular. And so one of the things on my list for the next couple of days is to figure out how to save this version of the dashboard back so that now that I've migrated everything away from Angular, everybody else can get that too. If I close this tab and go into the faces namespace, I can then open this up and I will get the deployment dashboard rather than the namespace dashboard. And this one, okay, the slide said we're going to go and do this in Grafana. I lied. I already did it in Grafana because that actually seemed a little bit more constructive. So you'll notice here, I now have this panel called HTTP requests and retries, which is not on the standard dashboard. And it's probably difficult to see, but the green line is requests to color.faces. And then you see yellow for retries to color.faces and blue for retry limited to color faces. And if I go down here to smiley, I see the same graph for smiley. You can also see that thankfully, these are not generally hitting their retry limit. That's kind of nice. But one of the things that we can do with Grafana is we can come up here, and that wasn't the one I wanted. Fine, I'll just click it over here. If we edit this, then this here is the query builder, or the way you configure this panel in Grafana. Here's the fun thing. This thing in the actual query is pretty much exactly what we fed to curl a few minutes ago. So once you get meaningful data out of curl, you can just paste it into Grafana. Or you can do it the other way and go through and edit this thing. One of the cool things is we can click this for builder, and now we get to do things like, oh, I want to look at this metric name. I want you to filter using these labels. I want you to do a rate, and then I want you to do a sum. And here are the labels do the sum by, and it will go through and figure out the actual query for you. So this can also be a good way to get a start on how you're going to do this thing. But the really cool thing about Grafana is, so you notice this says dollar namespace and dollar deployment and dollar outbound. Grafana is very powerful, and you can go through and define variables in the dashboard that will get filled in, and then you get to use them. Likewise, the rate, they say range. I like to think of that more as, sampling interval. And you've got this magic dollar under rate underscore interval, which is just magic. Trust Grafana and good things will happen, or something like that. And so all of these are things where you can make one panel that will then pick up variables that are tuned to the thing that you are looking at. So you don't have to go reproduce these freaking panels for every single deployment in your cluster. If we back out of this, then up here at the top, you see namespace faces, deployment face, and that's where dollar namespace and dollar deployment come from. We can find that by clicking on dashboard settings and going to variables. And if we go back over here, another thing worth pointing out is with outbound deployments, if we come over here, repeat for outbound. And so this whole row is going to get repeated for every one of my outbound deployments. If you come scrolling up here again and look at the dashboard settings, then inbound is grabbing the label values by looking at the request total thing and then looking at the deployment. Then the outbound is the destination deployment. We could refactor these and use, inbound HTTP and outbound HTTP. I'm not going to bother right at the moment, but you can do that. So, what was the other thing I was going to mention there? Oh yeah, the other thing I was going to mention here was on the normal deployment dashboard that ships from Linkerd. There's only one line on here because there's only one query. Actually, I think there's two. I think there's looking at request total to look at queries that were made with TLS, and then another one for queries made without TLS. But you can go through and delete any of these if you don't want that anymore. You can do lots of things. Actually, if I remove that and then I hit the run queries button, then there you go. That line just disappeared. Isn't that exciting? I shall now discard that because I don't really want that to be missing. Oh yeah, the other thing I was going to point out in here. You remember Tom was talking about transforms?
Don't do it.
This is where transforms happen. I'm not actually going to do it, but yeah, there's a ton of stuff you can do in
You're
here.
going to want to read the docs on this.
Very, very much so. But that's how you do it. So yeah, just FYI.
If you can't get there with the query, start reading up.
Yep. I have one more thing to show in the demo. Tom, was there anything else you wanted to point out about Grafana while we're here?
Yeah,
Grafana
you can select more than one thing too, right? So if you wanted to select multiple namespaces, multiple deployments, I believe when you drop those down, do they give you checkboxes?
Let's find out, shall we? Not here.
Sometimes I think there's a special way to do it, but like I've got it set up so I can pick more than one in one of my dashboards, so I can look at all of a particular type or whatever. There you go. Yeah, right there. So not there, but in that namespace, we can pick multiple deployments. So if you wanted to look at more than one deployment, you can do that.
Now you'll notice that this graph didn't change when I did that, and that is because this one was actually supposed to not be here in this demo because I got partway through it and realized that wasn't where I really wanted that. I wanted to do that differently. So just pretend you didn't see that. But if I do this, you'll now notice that I've got deploy color, deploy face, deploy smiley, and I don't have color 2 or anything like that. So yeah, that's pretty cool.
Yeah, variables are powerful. So you can build dashboards that aren't specifically to one particular thing.
Mhm.
And, then you can configure them with your variables as needed.
Yep. Yeah, Grafana's the thing that I find fascinating about the Grafana documentation is that they seem to assume that you already know how to deal with Prometheus very well. And so that can be a little interesting. But if you just kind of flip back and forth between the docs and kind of refer to both of them, it works out pretty well.
Another thing, if you open up and edit on like the request volume there or one of those panels and you edit that and you scroll down to the bottom of the queries and like throw a new query on there real quick.
Mm-hmm.
If you want to pick, yeah, I think you have to go
I'm
to the
just going to
bottom.
duplicate that one.
No, just like start with a fresh one. I think if you go to the bottom, there's a way to add another one. I can't see it. But like,
Right.
yeah, you can go in through the metrics browser and you can start looking for things here.
Yeah,
So
that's a good one.
just like you would do by querying the API, you can actually pick through here, and then you can see what labels are exposed for that particular metric, and dig down from there, and then you can just discard right when you're done. But this is a great way to find out. You're like, hey, how can I leverage this? What metrics are out there? How do I leverage them? How do I
Yeah.
get what I want? You can just poke right around here by just throwing a new query on and poking around. Then just when you're done, if you don't want to apply it, make sure you throw it away with discard.
So now I have a query for consider calculating a rate for outbound HTTP errors.
Oh, there you go.
Okay. That was actually kind of nice. Hey, that's a counter. Maybe you want to rate.
Yep.
So if I flip back over to Builder, then I have a nice, neat way to
And
say,
look right next to
hey,
it.
give me a rate. And now I can run the query again, and whoa. And that huge, big, long thing there, I believe, is the one that we are talking about here. I can then come down to options, and I can change the legend to be
Custom.
custom. Errors for face, which is, terrible, but there we go. Errors for face. So face is getting, a few errors a second. Oh, yeah, of course, because this is outbound HTTP errors total. And about 20% of the time I talk to the face workload, it's going to return an error and have to be retried. So, yeah, that makes sense. And look, it was very easy to add that.
They've got nice mechanisms in there for working through. You just have to make sure you read the docs. But this is a great way to poke. If you don't want to go down and curl a bunch of stuff, you can just poke around right here in your query builder.
Here's the big challenge if you do that, though. I just misspelled the name of face, and now it's just gone. If I want to make this really obvious for what it looks like a lot of the time when I'm messing with these things, run queries.
There you go. No data.
As far as I can tell, there is absolutely nothing in Grafana that will talk to me about, dude, you didn't get any data because there isn't nothing called FACZ.
There's no syntax error.
Likewise, if I come over here and I say outbound HTTP 3 errors, again,
doesn't care.
No data. It's not going to tell me anything like, dude, there's no such metric as that, which I think is honestly really unfortunate. I think it will tell me if I leave off a parenthesis or something.
Mm-hmm.
Yeah. Okay. So it tells me that. That's your one saving grace.
So there is syntax error, but it won't tell you that, hey, I didn't find a metric name that, or hey, there's no label like that, or it's very generic. So understanding the underlying is good, and being able to go down and look at which metrics you're collecting, based on where you're looking at it from, right? It's all about perspective. If I'm look here, this is what I can see. It's very important.
There was one other thing I was going to point out, which is that If I do this, I think I will get no data. But if I do equal match quote,
Mm-hmm.
I believe I will get all of the data.
Or is that null?
I think that might be. Well, I know that.
You can do star.
Yeah. I also know that there's a case where if you haven't selected a value for a particular variable, then if you do equal dollar variable, it will fail. But if you do equal match dollar variable, it'll give you all of them because you haven't selected any.
Yep.
And that was a bit of a gotcha for me.
Yeah, don't forget the match, and you can use wildcards. Like
Yep.
I do that quite a bit.
Yeah.
When I'm writing initial queries.
All right. The one other thing I was going to point out then is let's come back over to the demo. So you will recall I said that there's nothing special about Viz. You can just go and do all of your own. So in fact, there's a really stupid Python program that is a Prometheus client that does dashboardy stuff. Specifically, it is showing gRPC metrics for Emojibodo, a particular chunk of Emojibodo. And so we get to go through and see, oh, yeah, overall, Emojibodo is hovering around an 80% success rate. Ignore the handling connection for things and just look at the fact that the stats are changing over time slightly and it's doing reasonable things. And the way that works, again, I'm not going to cover this in detail, but it's deliberately doing everything the hard way. There is a Python Prometheus client. I didn't use it. I just used requests to go and do the moral equivalent of curl. But we literally have a request for look at the outbound gRPC route backend response statuses total metric for web in the Emojibodo namespace, talking to the voting service, turn that into a rate calculated over 1 minute windows, sum by parent name and parent namespace, which is pretty much what we were doing with curl. We have a similar one, exactly the same thing, except we throw in gRPC status equals OK, so that this will only give us successful gRPC. And this is my favorite line where we literally throw some parens around it and stick a slash in the middle of these two big honkin' complex strings. And that is a valid query and it works. And then you can read below about how we're also brutalizing this slightly to say, hey, turn this into a rate with a single value. But yeah, again, there's really nothing special about Viz or Grafana and what information they have access to. You can do a lot of stuff down at lower levels if you decide you need to. With that, yeah, lots of useful information. Things look complex. It's not that bad. Feedback, as always, Flynn at Buoyant or Flynn on the Linkerd Slack. Always remember the first law of metrics. You have to know what you need so that you can go through and put things together that are tailored to your specific needs rather than cursing at the people who did the canned dashboards for not anticipating your every desire. We would love to be able to just read your mind, but it doesn't really work that way, unfortunately.
And you can duplicate an entire dashboard in Grafana and then do whatever you want with it. So you're like, hey, yeah, I like a few of these panels, or I want to build something off of that. Duplicate it. Keep the other one pure and just boom.
Yeah, the one that I was looking at, the deployment dashboard that I was looking at started life as the standard Linkerd deployment dashboard, and then I edited it and saved it locally and things like that. It's slightly tricky to do that particular kind of thing because the Linkerd Viz, those little Grafana links, link to uh, Grafana dashboards with specific UIDs.
Mm-hmm.
And if you install the Linkerd dashboard that we publish on grafana.com, or grafana.com, grafana.net, whatever it is, if you install that one the normal way, you can't actually uninstall it, and you can't change its UID, so you can't take over it that way. Which the way I did that one, you can see in the repo. I actually removed that dashboard entirely and then manually imported my own. But looking at one of the things on my to-do list for the next couple of days is to figure out how to actually update the ones we publish to be a little bit better about this.
Yeah, when you do that, and if you want to export, you can export the JSON models. You can strip out the UID at the end in the last couple lines. And I would suggest that, like when I check the custom dashboards in that I make, I always strip out the UID so that I can cut and paste it into my sandbox and not have it, clobber something or overwrite something. It'll assign one at the time that you import it.
And the way you do this is you hit share and then you hit export. And you can go through and either look at the JSON or save it to a file. Then after you do that, Linky is kind of hiding this, but there's this little thing up here for new dashboard, import dashboard. You can drag the JSON file in, or you can paste the JSON, and off you go.
You can also go to the gear if you want to up there, like where you would go to save normally.
Yeah.
So if you get out of here,
okay.
Go back to the dashboard. Close.
This is something I kind of don't like about Grafana.
There you go back up to the gear up there. So it's cool. There's several ways to do this, and I didn't know you could actually just click that plus and import it. There's the JSON model right there. Now remember, when you export a dashboard from the GUI or you export a dashboard from the API, those are two different things. So be aware of that as well. And I'm not going to go into it, but read the docs. And if you import also, right? So be aware that there are two different formats as far as I'm aware that you can export and import, right? So when you're doing it from the GUI, make sure you're aware that that was exported from the GUI. So this is getting things to auto import is definitely a rabbit hole that you need to allocate some time to go down. I've spent some time on it and I have yet to get it working.
I just realized the other really critical thing I meant to say about Grafana while you're doing all your edits. So you notice I just removed that big panel up here.
Mm-hmm.
If I reload this page,
make sure you save.
The panel comes back. If you're in the middle of editing your little panels and everything like that, and you hit reload instead of, hang on a second, I got to get rid of Linky so we can see this. I mean, I kind of hate to get rid of Linky, but there we go. All right. If you click on this refresh thing, that is refresh the dashboard. Mm-hmm. That is a different thing from reloading the page.
Yep.
So if I come over here and I remove this again, yes, I want to remove that. Then I can hit this button until the cows come home and it's fine. But the moment I reload, it's back. And what you need to do here is for the dash itself, you remove it and you go up to this little floppy disk thing and you say, save my dashboard. You don't have to do a comment. And now if I reload, it's gone until the next time I re-import this from the JSON file because, right. Likewise, I come over here and I start editing this thing. I said if I start editing this thing, then once again, I can refresh the dashboard. I can go through and delete things, and then I can run queries, or I can refresh the dashboard. And if I reload the page, it's right back where it used to be unless I apply or save. If I apply, I still have to save the dashboard, or if I reload the whole dashboard, it'll get reset. Learn from our burned fingers.
Yeah. Know which way you're exiting wherever you're at, right? Like if you're just playing with something, discards the safe way.
Yep.
But if you apply it, that will apply to the dashboard that's loaded in the browser right now. But until you save, it's not going to be one that you can go retrieve from the dashboard section.
Yep. Yeah.
Sounds like you're doing lots of edits. Comments are handy, especially if it's something you're collaborating on. But they're not required.
Yeah. Tom, I think you probably got as many burned fingers as I did on that one.
Oh yeah,
Yeah.
I've had to go back, and I will go to the JSON model and copy the entire thing, and go put it into my repository, and update that. Like, you know, you could
Over and
never
over
be
and
too
over again.
cautious if you're doing meaningful work, right?
Yep.
Once you get to a checkpoint, save it, grab the JSON model, put it into your repo, and commit and push,
Yeah.
because
I mean, it's source code,
yeah,
even if you're producing it using a browser.
yep,
That's really what it comes down to.
yeah.
All right. Next Service Mesh Academy, September 12th. The top 5 things you need to know about Linkerd 2.16. Some of which we kind of already talked about this one with metrics and stuff, but we get to do a much deeper deep dive with some of
Oh
that.
yeah.
I have been doing this demo on Buoyant Enterprise for Linkerd. You should check it out. It's good stuff. I think that's about all there is to say on that one. And yeah, I do not know. We got a couple of minutes for Q&A. I haven't seen anything in the workshops channel.
It's been a little quiet.
Yeah, it's been awfully quiet. I guess that might mean that we're just confusing everybody.
Too many dimensions.
If I look in the chat from way back when, is there a repo to follow along with the workshop? Man, I really hope we answered that question in a timely way while we were doing this.
Yeah, I think I've brought it up a couple times, but let's go ahead and
We'll
take
put
one
that up
more
again
look.
just for the fun.
Yes.
For the fun of it.
And there's a lot of stuff on GitHub. Like, again, this directory is a subdirectory of the main Service Mesh Academy repo, which is what you would clone. And there's a ton of stuff in there. Not all of it fresh and new, but these are great resources that you can go and either use with or without the recordings. Again, SMAs are recorded. So if you want to go and, watch those, the replays, if you want to go back through some of these things, you can go to buoyant.io in the Service Mesh Academy section. And this is, again, the repo that you would go to get to all these other good things. You were using Faces. The Faces demo's available as well. It's a repository. So all that good stuff is out there. You can leverage it, or go poke around Buoyant.io. There's all kinds of cool stuff out there.
I was also using Emojivoto, which is also available under the Buoyant.io repo. I mostly use Faces because I like the fact that it's so blatantly obvious when it's broken and when it's not. But, doesn't mean you have to.
Yep.
But other than that, I think that'll do it then.
Yeah, hopefully everybody got something out of this. And those of you who are going to watch us in the future, again, hopefully you will get something out of this. Join the Slack.
Yep.
So you can join the Slack. We also have a forum. You can reach here at linkerd.buoyant.io. Come out, ask questions, participate. If you know the things, answer the questions. It's a big community, and we're all here to help each other.
I don't think we have. Oh, yeah, here we go. We do have the Slack link as well.
There you go.
The Slack.linkerd.io. The workshops channel is your friend.
And you can do it in the future if you're watching us in replay. I'd say if you're 100 years down the road, probably not. But like in the near future, feel free to throw questions up there. We'll see it.
If you're 100 years down the road and you're watching this, then
and you're still using a service mesh in Kubernetes,
that's pretty cool.
That'd be amazing.
Retro computing at its finest.
Yep.
All right. Well, thanks very much. We'll see you again next month.
Have a good one.